college algebra students. I hope things are going well with you and you're sort of settling into this new normal. This is a very short little section. It's section 4.3 on the properties of logarithms. Make sure that you're doing your My Math lab work. Don't forget about that and let it pile up on you. This entire section is really just about these three properties that you see listed up here at the top. So we have a multiplication property, a division property, and a power property. Okay, so here's what they say. They say that if you have a single logarithm or log, and you have two items in your argument that are multiplied together, you can split it up into addition. You can take the log, leave the base the same, don't do anything to the base, but you can take these two items in your argument that were multiplied and separate them and put a plus between it. Okay, the division property says you can do the same thing if you have two items that are divided, separate them, put a minus between them, don't change your base. And then last but not least, the power property says if your argument has an exponent in it, you can take that exponent off and put it out in front of the whole logarithm and make it a coefficient in the front. And so you can go both ways with these. You can be starting over here and turn them into one log. We call that condensing. You take several logarithms and condense it. Or you can take a single logarithm and expand it and go that way and split it into as many other logs as possible. Just remember that your base never changes in that situation. So let's use the properties of logs to expand these logs as much as possible, okay? Because if you notice, we only have one log in each example. So we're going to expand it into as many other logs as possible. Now, when we can evaluate it, make it a whole number, not a decimal or anything strange, then we're going to do that. Otherwise, if we can't, we're just going to leave it alone and simplify our answer the best that we can. Okay, so here we go. I noticed in example A that my argument has two items multiplied together. That means when I expand it, I'm going to take those items and add them. So I'm going to have two logs, same base, added together, and I'm going to have the first item as the argument of the first log, and the second item as the argument of the second log. There's no little special trick here. There's no whole number that either one of these would produce. Both of these would give us decimals. So we're done. That's our answer. Very straightforward. Okay, let's take it a little further. Let's look at this next one. In this example, we have a natural log. Okay, so we don't want to forget what we have here. In our argument, we have two things going on. First of all, I notice we have something being divided. So we're going to have two logs that are subtracted. I also notice in my numerator, I have an exponent. Well, when I expand them, I take that exponent off and make him a coefficient. So I'm going to have several steps here. Now, some of you are so good at this already, I'm sure you can just jump right to the answer, but I'm going to take my time. So first thing I'm going to do is separate this guy, okay, and he's going to have a minus because my items are subtracted. Now my base is understood to be an E, so I don't have to put it there. We're going to deal with that in a little bit. Okay, the numerator goes with the first one. The denominator goes with the second one. Okay, now normally I would be done except I have two other issues, okay? What I see here is that I have an exponent, which normally I would just throw right in the front there. But I also realize that the base of this exponent that's in the argument is the same as the actual hidden base of my natural log. And if you remember, if these are the same, then these guys cancel. And I'm just left with 7 minus ln of 7. Now, another way to have done this, if you see it a different way, would have been to go ahead and do that power property, to take that 7 off and put it in the front. You don't even have to put a dot there. and you're left with this. We know that the base is really an e. This is going to cancel down into just a 1. 7 times 1 is 7. So this would be another way to end up with this answer. But if you see it from here, it's kind of nice to just go ahead and cancel that out. And this exponent becomes the item that you're dealing with. Okay, let's try this one. I have two items here multiplied together. I have this number, 2,401, and I have the letter X. Okay, here we go. So because they're multiplied, I'm going to be adding two logs together. The first one is going to have the argument 2401, and the second one's going to have an X. Now, we have to be careful here. Let's go to our calculator. Okay, so I do have the fancy schmancy calculator where I have that special log button that I can access, but I know most of you don't. So we're going to do a change of base formula and just see. If I go back up to this guy, and I just want to check and make sure this is not a whole number, I would do regular log of 5 divided by the regular log of 3. And sure enough, that's a decimal. I don't want that, so I'm going to leave it in this form. If I try this one, regular log of 2 divided by regular log of 3. Sure enough, that's also a decimal. I don't want a decimal, so I'm leaving it just like this. Okay, if I come down here and look at this one, if I do log of 2401 divided by log of 7, I get a whole number here. I get a whole number. And that's actually because 7 to the 4th power is 2,401. Because I can reduce this guy right there to a whole number, I'm going to write that over as a whole number. Now, I never would have guessed that would have worked, but it's always a good idea to try. Now, I know this one is not going to reduce because, of course, there's an X there. So I'm going to leave it like this, and this is my answer. Now, I could have also tried the ln of 7, but that's not going to work as a whole number either. Okay, so it's always a good idea to just try and see, could some of these crazy ones end up being a whole number? And if they are, go ahead and do that. If they only become a decimal, leave it alone. Okay, all right, let's look at D. Oh, D has a lot happening. So I have a division. Okay, I know that's going to be a subtraction when I expand it. And I also have a root. Well, I can't have a square root in an argument, but remember, the square root of X can be written as an exponent of 1/2. So I can rewrite this. Okay, well, I'm going to leave my base the same, and I know I'm going to have a subtraction. The numerator is going to go with the first log. The denominator is going to go with the second log, but I'm not going to write the denominator the way that I see it. I'm going to rewrite him with parentheses indicating the whole thing is under the power of 1/2, and I'm going to put that as my argument. Okay, now I am far from done here, folks. This is a whole number. So if I go back with my calculator and I do log of 64 divided by log of 4, I get a whole number. Now, for those of you that do have the fancy calculator, let's just see if we remember how to do that. Remember, to do that, we would go to alpha, is it F2? Look at that, I guessed. Alpha window, I go down here to log base, and I could have done there exactly the way that I see it and also gotten a 3. So you also have that option. Okay, now I need to clean this up. This is a power property. I'm going to take this 1/2 and I'm going to move it in front of the log base 4 of x plus 8. And that is the final answer. There's nothing I can do with this particular argument. It is what it is. I don't have 2 logs there. I just have the 1 log, and this argument happens to have 2 pieces, which is allowed. So he is now completely expanded. All right, last one, E down there, okay? I have two items multiplied together, so I know that I'm going to be adding 2 logs. I take the first item, and then I take the second item. Now this has an exponent. I'm going to move it to the front. I get 7 log base b of x plus log base b of y. Now I can't even pretend to enter that in the calculator, so that's the end. So really this is just another way for you to write a logarithm. Why are we doing this? Well, because next week or in the next section, depending which class you're in, we are going to start solving some equations with logs. And sometimes we need this skill to be able to solve the equations depending on how complicated they are. Okay, so let's turn our page. We're on page 13 now. We have one more little guy up here, F. He didn't fit on the same page, so we want to do him. And then we're going to practice condensing our logs. Okay, so here we go. We have everything I could think of happening up here. I tried to just put every issue into one giant log. So we have our work cut out for us. Okay, first of all, let's write this log over using only exponents. So log base d of a to the 1/2 times b to the 5th over c squared. There we go. Okay, we wrote it over. Now, let's focus on our numerator. Okay, in our numerator, I see log of a to the 1/2 multiplied, which means I'm adding, log of b to the 5th. Oh, I forgot my base. Squeeze a d in there. They each get a d, right? Okay, then I have a denominator. What do we do with a denominator? We subtract him. So I'm going to put this guy in parentheses, indicating this is the numerator. Whoops. And I am subtracting log base d of c squared, which is my denominator. Okay, well, we got a lot of exponents there. So now we need to take every exponent in front of his particular log. So our new numerator, good gracious, okay, I'm sorry, our new parenthesis is going to be 1/2 log base d of a plus 5 log base d of b minus 2 log base d of c. And that's our final answer. Now, if you do not put parentheses in, that's okay. I'm not even convinced the parentheses are an option on my math lab or the test, but in my mind, they should have them. So parentheses are optional, but you do need to make sure that your final expansion has as many logs as you have terms. Well, I have 1, 2, 3 terms, 3 logs. And your final expansion has no exponents. And make sure each of those logs has the same base, the original base that you started with. Okay, some little tidbits there. Okay, well, now let's go the other direction. Now let's condense. So if you notice on A through F here, we have multiple logs, 2 and 3 logs each. So now we want to condense these as a single logarithm. And we don't want any coefficients. Coefficient is 1. So if you have a coefficient in front like b does, they want to be transferred up to the argument as exponents. Okay, we're going the other direction now, so we have to shift our thinking a little bit. Okay, here we go. So I notice I have 2 natural logs. This is going to get written as 1 natural log. And both items here are being subtracted. That means we're going to divide. The first argument is going to go on the top. The second argument is going to go on the bottom. And it just so happens I can even reduce it. I can try the natural log of 3 in my calculator. It gives me a decimal, so I'm done. I have 1 single log and I have a coefficient of 1. So that's how it's going to work, okay? All right, I notice here in the next one, I have 2 logs, so I'm going to have a single log base b, but I also notice I have coefficients, so I'm going to go ahead and put those coefficients as exponents. I like to take it one step at a time. Some of you could already have this done and be on to C. But here we go. All I did was put the 3 as an exponent on the x and the 2 as an exponent on the y. Okay, now I'm ready to make a single log base b. Your base never changes no matter how many logs you have. I notice I have a plus in the middle, which means we're going to have the 2 arguments multiplied together. First argument is x cubed, and he's multiplied by y squared. You can leave it just like this, or if you wanted to, you could even put parentheses. The parentheses are optional since there's just one chunk there. Okay? All right, let's try the next one. All right, I don't see any coefficients to put in front, so I'm ready to go ahead and make a single log base 4. I see subtraction, so I know I'm dividing. First item is my numerator. Second argument is my denominator. Oh, look, I can reduce log base 4 of 4. And then this is that little special situation when these are the same, the whole thing kind of cancels down and you end up with 1. If you're not so sure about that, you can always go to your calculator. Log of 4 divided by log of 4. There's your 1. Okay. All right, next. Okay, here I see 2 coefficients. Let's handle those first. I'm going to put them up here as exponents. So I'm going to have the natural log of this argument here raised to the 4th minus the natural log of x raised to the 8th. Okay, now I see I have a minus between them. So I'm going to write the natural log over and I'm going to have a division. This first argument with all of its stuff becomes the numerator. Second argument becomes the denominator. Now I can't reduce this. I can't reduce these exponents because it's not the same thing. It's not the same base that they're on. So there's not anything I can do. I can't distribute that. I can't do anything else. Don't get crazy on me just because you're working from home. That's the best that we can do, right? Because this means there's 4 packets and this means there's 8 x's. So that's 2 very different terms there, okay? All right, letter E, my goodness, look at all of this. Okay, well, at first glance, this that we did up here in F looks a whole lot like the E we have down here. Okay, well, you know I like to handle my coefficients first, so let's do that. My pencil doesn't want to cooperate today. Okay, so I'm going to have in my parentheses log x raised to the 1/7 plus log y 4th, close parentheses, minus log of z to the 6th. Okay, there we go. All right, now I see these are added together, which means that I'm going to have a multiplication situation here, okay, and then a subtraction, which means I'm going to have a division with this as my denominator. So here's my numerator, x to the 1/7, y to the 4th, those are multiplied together. My denominator, x to the 6th. Now we are not quite done here because we don't ever want to leave an exponent as a fraction. So we know that x to the 1/2 is really the square root of x. So what do you think x to the 1/7 is? Okay, he's actually the 7th root of x over y to the 4th, z to the 6th. So if you have a fractional exponent, go ahead and change that back. Remember, your denominator is the index, your numerator is the exponent. Okay, that was very tricky. That was everything I could think of there. Okay, last one. It's not so bad, but let's make sure we can do it. All right, I see 2 logs, no coefficients. My 2 logs are subtracted, which means division. This, because it's an argument that's been put into parentheses, is one chunk that travels together. That's the top. This, in parentheses, is one chunk that travels together. That's the bottom. I can't reduce this. I can't cancel anything. That's your answer. Okay? So I don't think it's hard. I think you guys will be great on this. It's very, very straightforward. We just have this little part of page 14, and then that's the end of this section. So it's really pretty short. Okay? All right, here we go. So use common logs or natural logs and a calculator. Okay, we'll need our calculator to evaluate this expression. Round to 4 decimal places. All right, this is just to remind you how to do a change of base property, but to me it looks pretty complicated. We don't even need that. All right, so what we have here is log base pi to the argument 56. We want to be able to find this answer and round it to 4 decimal places. Well, if you have the fancy calculator, you're doing alpha, window, down here to log base, and you're putting in pi. Where is my pi? Let's think. Let's look at this for a second. I haven't used that button in so long. I just saw it. Where did he go? There he is. Okay, there he goes. He was right here on this little caret. Okay, and then a 56 is your argument. And there's your answer, 3.5164. Okay, if you don't have that fancy formula, you're going to need to do change of base. So here you go. You're going to do plain old log of 56, hit enter, divided by plain old log of pi. Same answer. Here it was with the fanciness. Here it is with the change of base. Okay, so your answer is going to be 3.5164. And again, if you need to use that change of base, remember you're just looking at plain old log of 56 divided by plain old log of pi, and that'll do it for you. Okay. All right, last question here. Use a graphing utility. Well, we don't need to do that. To graph the function log base 5 of x plus 2. Okay, well, if we did want to do that and we had a graphing calculator, we would go to y equals. We would have to go up here and do our alpha window. Okay, log base 5 of x plus 2. And we would graph it. Okay, I have a strange window, so let's fix my window. Let's do zoom standard. Okay, and there it is. All right, if we don't have this graphing calculator to use, let's think about this a minute. So regular old log base 5 of x is supposed to look like this. He's supposed to come down here, come up through 1, and off he goes. Okay? All right. Well, this plus 2 means that we are going to shift it 2 units, to the left. We're going 2 units left with that plus 2. So this x-intercept is going to move 1, 2 units to the left. So instead of having an x-intercept at positive 1, you're going to have an x-intercept at negative 1. And there we go. So that's what it actually looks like. And remember, this information came from the last section in 4.2. But here it is. If you wanted to look at it, I'll even zoom in a little bit. There it goes, right through an x-intercept of negative 1. If you wanted to see it blown up on a graphing calculator, there it is. But we figured it out just from our knowledge of the log parent function, and then we scooted it 2 units to the left because we had a horizontal shift here of +2. All right, kiddos, that does it for 4-3. I will tell you 4-4 is kind of long. So it is, let's see, we start on page 15, we go through 19. So we will start that next. That'll be your assignment for next time. And I hope you're doing well, and I miss you. Bye-bye.